In a third situation, we have again a horizontal initial velocity at 50 centimeters per second. Since the velocity is horizontal, the y component is 0. We'll see later what to do when the y component isn't 0, but once we get the idea here, it's not too difficult. And we find that the horizontal range is 250 centimeters. Now, if something goes horizontally off the edge of a platform at 50 centimeters per second and falls to a level surface traveling 250 centimeters, then how far did it fall? Again, pause the playback and see what you think. Now here's the solution. In the first place, the x motion is 250 centimeters at 50 centimeters per second, which implies a delta t of 5 seconds. That is, if we look here, the x velocity is going to remain constant because there's no acceleration in the x direction. So we're going to continue to move at 50 centimeters per second. How long does it take to move 250 centimeters? Obviously 5 seconds. 50 centimeters every second is going to take 5 seconds to move 250 centimeters. We don't need an equation to do that. Now we want to analyze the vertical motion. We have to analyze the vertical motion to find the vertical displacement. So the vertical motion, we're going to have an acceleration of 9.8 meters per second squared for 5 seconds. What can we conclude from an acceleration of 9.8 meters per second for 5 seconds? Well, we could put that together with the initial y velocity of 0 and use an equation, but we don't need an equation. If we understand the definition of acceleration and the definition of velocity, we can easily reason out the acceleration. And we should always try to reason things out rather than reaching for an equation. If we can reason them out without reaching for some canned equation, we increase our understanding and our ability to reason. And that's very important in physics and in a lot of other areas. Now, vertical motion, we have this acceleration for 5 seconds. What can we conclude from an acceleration of 9.8 meters per second squared for 5 seconds? Well, if we understand what this means every second we change by 9.8 meters per second, then in 5 seconds our change in velocity is going to be 49 meters per second. This should be a familiar line of reasoning. Then, since our initial velocity is 0 in the y direction, and our change in velocity is 49 meters per second, we're going to, of course, have a final velocity of 49 meters per second. And our average y velocity, since we have uniform acceleration, will just be the average of the initial and final. And we average those and we get 24.5 meters per second. So now we know that we average 24.5 meters per second from a delta t of 5 seconds. And we can come up here and see that our y average velocity 24.5 meters per second and delta t of 5 seconds implies a displacement, well, 24.5 meters every second, 5 seconds. It's going to give us 122.5 meters. Again, we shouldn't need an equation to figure that out.